If you follow AI research, especially generative models from 2023, you will come across the keyword flow matching. But if you dive into the flow matching paper to study it, the abstract is enough to scare you off.
You should know these preliminaries.
What are these preliminaries? First, continuous normalizing flow, which is CNF. Second, ordinary differential equation, ODE solver. And lastly, diffusion. They require us to understand several concepts before grasping flow matching. But these concepts are already well known, so after reading this abstract, the first thing that came to mind was, I know, I've been through all this, but if you dive into the main body, the others don't make it any easier. What is the probability path? It feels like probability is moving forward somewhere, but the phrase sounds unnatural. Then the next thing that bothers you is the loss. The loss function is mean square error. It's straightforward, right? However, the loss regresses the vector field. What on earth does that mean? What is the meaning of regressing a vector field? This idea is so abstract that it interferes with building a solid understanding. So before I start explaining flow matching, let me first explain what a vector field is. What is a vector field? According to Wikipedia, a vector field is used to model speed and direction throughout space. For example, it models wind or physical forces, such as magnetic or gravitational forces. All these forces affect something and cause movement. The two primary keywords here are speed and direction, and throughout space. Speed and direction correspond to vector, and the phrase throughout space corresponds to field. A vector field assigns a vector to every position in space. In other words, a vector field is a function. It takes a position as input and returns a vector as output. To put it differently, let's think about it in this way. A vector represents a tendency that makes something move, and a vector field is a function that generates a vector based on an input position. So now we understand that a vector field is a concept related to space, and that's all we need to understand flow matching. The next step is understanding regressing a vector field. Personally, I think this phrase sounds a little arrogant, don't you? It's almost like the others don't want people to understand their work. Let's think about regression for a moment. In deep learning, regression refers to training a model to predict a desired value, right? For example, when training a model to predict house prices, the model takes some inputs and produces a numerical value representing the price. Then the loss between the predicted value and the true value helps adjust the model to make more precise predictions. It's easy to imagine a model generating numerical values. However, I just explained that a vector field is a function, not a simple numerical value, and that's where the confusion starts. In the next video, I will explain what it means to regress a function. Thank you for watching this video, and don't forget to subscribe for the next one.